Everyone knows that a giant rock from outer space hit the planet millions of years ago and wiped out the dinosaurs. Now with advanced technology, researchers have been able to put together a new timeline showing what really happened. And not only this, they think they know where the giant asteroid came from. Is Earth the target for another huge space rock? And would we be able to survive? You'll be surprised and probably shocked at what NASA astronomers recently discovered. So now get ready to experience the disaster that almost wiped out life completely on Earth. The giant asteroid's impact into shallow waters in the Gulf of Mexico 65 million years ago was bad enough, but then an amalgam of additional disasters ensued. Rocks fell from the sky, wildfires ignited, and tsunamis inundated distant shorelines. The researchers found that the first day of the Cenozoic was peppered with cataclysms and released a new record of this day of chaos in Proceedings of the National Academy of Sciences. The timeline was developed using high-resolution photography, microscopy, computer tomography imaging, and magnetic measurements of hundreds of feet of sedimentary rock recently recovered from Chicxulub. One of the largest impact rate is on Earth, and it all began like this. Imagine you were somewhere in North America about 65 million years ago when dinosaurs ruled the Earth, and you were looking up at the night sky. You would have probably seen what appeared to be a bright star shining off into the distance, that if you watch this peculiar light for an hour or two, the object would seem to grow in brightness, but barely move. What you would be looking at is not a star, but a huge asteroid, somewhere between 11 to 80 kilometers wide, on a direct intercept course with the Earth, at 72,420 kilometers per hour. Hours later, the asteroid plows through Earth's atmosphere, heading straight for where the Yucatan Peninsula is today. At impacts of that speed, Earth's atmosphere acts like water. Smaller space rocks, called meteors, hit the atmosphere like pebbles thrown into a pond and decelerate rapidly at high altitudes, burning away from the friction of the atmosphere, while some bigger pieces of rock survive and fall to Earth. But the mountain-sized Chicxulub asteroid hits our atmosphere like throwing a boulder into a puddle. It maintained its velocity and plunged through the entire 60 miles of atmosphere in just 3 seconds. The asteroid shrieks over Central America, emitting the mother of all sonic booms that would shatter eardrums across all the continents. The dinosaurs were likely terrified and running in all directions, having no idea what was just about to happen. But if any animal was close enough to see the asteroid, they would have been instantly vaporized within minutes. In fact, except for sea turtles and crocodiles, no four-legged animal larger than 25 kilograms would survive. The mountain-sized space rock falls so quickly that the air itself cannot escape. Under intense compression, the air heats to thousands of degrees almost instantly. Before the asteroid even hits compressed, superheated air vaporizes much of the shallow sea that covers the Yucatan. Milliseconds later, the rock plunges through what's left and slams into bedrock. In that moment, a chain reaction of events occurs. The impacting asteroid exerts so much pressure on the Earth that soil and rock flow like fluids. The flowing, up and down movement of the Earth is like the double splash of someone doing a cannonball in a swimming pool. The initial splash in all directions is followed by a delayed, vertical splash when the cavity created by the asteroid rebounds to the surface. The first wall of Earth, gouged outward at the moment of impact, is more than 32 kilometers high. The impact hole nearly breaches Earth's mantle, and when the cavity rebounds to form the delayed, vertical splash, the Earth rises at over 1,600 kilometers per hour to heights taller than Mount Everest. Within minutes, this mountain of debris almost entirely collapses in a series of secondary explosions, leaving behind a smaller mound, called a crater's peak ring. At the same moment, the asteroid strikes the Yucatan and applies its pressure to the bedrock. It converts the kinetic energy of a 7.5 billion-ton rock, traveling 16 kilometers per second, into searing heat. In an instant, the Chicxulub impact delivers approximately 1 septillion, 300 sextillion kilojoules of energy, more energy than 1 billion Hiroshima atomic bombs. The kinetic energy transferred by the asteroid to the soil, rock and air excites the molecules to temperatures far hotter than the surface of the sun. The heat rips electrons from atoms, ionizing the air into an expanding fireball of plasma in excess of 10,000 degrees, turbocharged with vaporized rock that blasted out at hypersonic speeds. The heated, rapidly expanding air and near instantaneous conversion of Earth to gas, combined with the impact shock wave itself, forms a massive blast wave of pressure, expanding outward at more than 1,600 kilometers per hour. If this asteroid hit the same spot today, the blast wave would vaporize you in Texas, deafen you in New York, and blow out glass windows in Buenos Aires. The Chicxulub impactor rings Earth like a bell. Waves in Earth crust radiate away from the impact zone at 4 kilometers per second. The waves then trigger fault, slipping earthquakes across the continent. If you on the other side of the world, you'd feel the ground shaking 30 minutes after impact. The impact triggers tsunamis as high as skyscrapers. The first of them hit Gulf coastlines within the hour. Waves ranging from 600 feet to perhaps as tall as 1,000 feet smash into what is now Mexico and the southern United States and flood tens of miles inland. The waves temporarily reverse the flow of rivers, rushing up riverbeds like 30-foot tidal bores. Tsunamis smash into the eastern coast of the United States and 6 hours after impact max out at 600-foot high walls of water that slam into Europe, Africa, and the Mediterranean coasts. Within 15 hours of impact, waves arrive on every coastline on the planet. Depending on local topography, the ocean sweeps away anything in its path and sucks it back to the sea. When the waters finally retreat, it already sounds like Armageddon, but even more disasters are on their way. When the big rock strikes, its splash accounts for 25 trillion tons of Earth that it launches on ballistic trajectories, some at speeds that exceeds Earth's escape velocity. These rocks excited Earth's gravitational pull to either orbit the sun, and some of this material probably reached the moon. But the majority of ejected debris returned back to Earth within the hour. These glass-like chunks, called tektites, some as large as buses, but most the size of marbles, pelt the Earth at speeds ranging from 160 to 320 kilometers per hour. In lethal quantities, regardless of where any remaining dinosaurs were on Earth, they were hit with this fiery hailstorm. But these glass bullets didn't need to hit the dinosaurs to be fatal. As these tektites fall, their friction with the atmosphere emits enough thermal radiation to set fires across the planet. By some estimates, the combined heat of the returning embers keeps the planet to the equivalent of an oven set to broil. Most of the world's trees burn, which is perhaps why the only bird species that survived the impact are those that nest on the ground. Of the few larger land animals to avoid extinction, nearly all have had some means of escaping the heat. They either could burrow, like small mammals, snakes and lizards, or escape into water, like crocodiles or turtles. Even if the poor dinosaurs were on the other side of the world, they would have needed to find protection from the initial heat blast. In a final piece of terrible luck for the dinosaurs' chicks, a loop happens to strike an area rich in oil and sulfur. The impact ejects 100 billion tons of vaporized sulfur and 30,000 quadrillion gallons of water into the atmosphere, which then condenses into massive storm clouds and falls back as torrents of acid rain that acidified the oceans. In the higher latitudes, continental-wide, snowstorms deposit tens of feet of snow per day. But the global deluge doesn't last long, because in addition to water, Chicxulub vaporizes and explosively ejects 150 football stadiums worth of oil from the Yucatan bedrock. This oil condenses in the stratosphere as a black, sooty layer, covering the Earth like a coat of black paint. Unlike the sulfur and wildfire smoke, the carbon circulates high above the cloud layer, stopping it from raining back down. And that becomes another big problem. The soot layer remains in the atmosphere, reducing the amount of sunlight that reaches Earth's surface by 90% for at least 2 to 3 years. The initial oven-like heat brought on by the returning tektites is followed by a deep and long-lasting freeze. Global temperatures drop by an average of almost 50 degrees. The only place on Earth to avoid this deep freeze are Madagascar, India and Indonesia. which were tropical islands during this time. In the global chill, evaporation almost ceases, dropping rainfall by 80%. Nearly every spot on Earth outside of these tropical islands dries into a desert. Where did this giant rock come from? And is there another one out there headed for US? Researchers, using a supercomputer, studied asteroid evolution using data from known asteroids. The two-member team of Avilo, Abundamir Siraj, suggested that the Chicxulub asteroid likely originated from the Earth cloud, a sphere of debris at the edge of the solar system. It could have been a much larger comet that was pushed off course by Jupiter's gravitational field and sent close to the Sun, where it broke into several pieces. These fragments can cross the Earth's orbit and hit the planet once every 250 to 730 million years. Judging from this study, it's not a matter of if we could be hit by another giant rock from outer space, but when on Saturday, December the 11th, 2021, NASA revealed that a 330-meter-long asteroid, named for 660 Nereus, screened past Earth, around 38 million kilometers, at a speed of 6.5 kilometers per second. While you might not think this is very close, any slight deviation in its orbit could put it on a direct course with us and smash into the Earth. In the future, astronomers are tracking this potentially hazardous rock and say it'll come within 1.1 million kilometers of Earth on Valentine's Day in 2016. Buy your flowers and get those proposals done early. Just in case, keep in mind, the asteroid that caused the Chelyabinsk explosion in Russia in 2013 was just 20 meters in size. The bad thing is that we don't have any known way to defend the Earth from a giant space rock. However, NASA's DART mission, or Double Asteroid Redirection Test, try to see if a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, causing a kinetic impact that could push the asteroid off a collision course with the Earth. DART's target is Dimorphos, an asteroid moonlet which orbits a larger asteroid named Didymos. The spacecraft is set to arrive in late September 2022, when the Didymos system is 11 million kilometers from Earth. However, it estimated that the collision will change the speed of the moonlet by a fraction of 1%, stopping at 10-kilometer wide or bigger asteroid hurtling towards the planet at more than 72,000 kilometers per second will take a lot more than a small spacecraft impacting it. Perhaps the world would need to try nuclear weapons like in the movie Armageddon. Maybe you have an idea how we could stop a world-ending asteroid and you'll become famous. Let us know what you think, and make sure to stay tuned here for more exciting stuff happening in our universe. Thanks for watching.